Alright guys, we are going to finish the 2019 Level 1 Acids and Bases paper today by finishing question 3. Again, hopefully you have enjoyed my tutorial video. Subscribe if you haven't and smash the like button just to help the channel grow. Right, question 3, let's get started. So we got 3 bottles of acid, 3 unlabeled bottles containing different colorless solutions known to be HCl, NaCl, and NaOH. Now this is something that you should need to do. You should memorize acid, the 3 types of acid that you get given. You normally be examined on is HCl, H2SO4, and HNO3. So this is an acid, and in level 1, as a level 1 science student, if you see anything hydroxide, anything oxide, anything carbonate, these are basic, these are bases. And then if you see something like it's a metal and non-metal from your table of ions, this is a neutral thing. Okay, now what I said about the OH and oxide, that's not necessarily true all the time, especially the more chemistry you do later on. But at year 11, that's pretty much you know, the rule you just have to remember. And the solutions were tested against red litmus paper and baking soda. So baking soda, you can see there's a carbonate there, so this is a base. Okay, so that's how you can know. You see anything like has carbonate at the end, you see anything with hydroxide at the end, anything with oxide at the end, like a metal oxide, those things are normally alkaline. So if you put HCl in red litmus paper, this will stay red, because acids always go red. Now if you put acid plus carbonate, acid plus carbonate will give you acid plus carbonate will give you salt, which you can't see, water, which you can't see, and carbon dioxide, which you see as fizzing. Okay, so you're going to see gas being produced, you're going to see fizzing because CO2 is being produced. NaCl is going to stay red because it's neutral. Litmus paper only turns from red to blue if you have a base, so this will go from red to blue. Neutral things no reaction with NaHCO3 and sodium hydroxide. With that, there's always no reaction with that as well. Okay, explain how the observation allow you to identify each solution, give reasons for any changes. Okay, so you just need to explain that HCl is an acid, and acid in litmus paper stay red, to stay red in red litmus, and then you can then talk about the reaction producing carbon dioxide when it's put with a carbonate. The next one, you have NaCl. NaCl is neutral. That means it stays red in litmus paper, and then there's no reaction because neutral and base doesn't react. And then you can talk about NaOH is a base, and then base, so it would turn blue turns blue in red litmus, and there's no reaction because base doesn't react with the base. Okay, so this question is becoming more popular, especially in the last 2 or 3 years, comes up quite frequently. But just remember the 3 types of acid you need to learn, and then look at the end of the compound, like say hydroxide, oxide, carbonate. Those things tend to be basic. Okay, so here we go. Sodium hydroxide will turn it blue because it's a base. Baking soda to the remaining solution, HCl is an acid. You undergo neutralization reaction, it will produce bubbles, fizzing because of carbon dioxide. The other thing doesn't react at all. Okay, next part. In an investigation, copper sulfate can be made, blah, blah, blah. Now the only type of reaction you learn for acids and bases is neutralization reaction. This is a free achieve tick. You only need 8 or 9 to pass. This is a free one. Okay, so just remember, I've seen so many precipitation reaction, displacement reaction. You probably do the other standard. Most schools don't, some schools do, but for acids and bases you only do one type of reaction, which is neutralization. If you say acid-base reaction, I think we will give it as well. Now let's write a balance symbol equation, word equation for this. So this is copper sulfate being made by reacting solid copper carbonate and H2SO4. So we react copper carbonate, and like I said with the previous one, this is only achieved for the word equation. So I normally don't even do it because it's achieved. This will give you copper sulfate plus water plus carbon dioxide. Okay, so simple equation, copper carbonate is CuCO3, sulfuric acid is H2SO4, copper sulfate is CuSO4, water is H2O, carbon dioxide is CO2, and this equation looks to be balanced already. Okay, so that's already balanced. Nothing needs to be done, and this is, let me just double check. Copper carbonate, sulfuric acid, copper sulfate, water, CO2. Yep, everything checks out. So this is a mirror equation. Let's look at the next one. Describe how you make solid copper sulfate crystals in the school laboratory. I'm just gonna go straight into the answers. It's pretty much just mixing the things together. Wait until you finish bubbles, and then you just get the salt. That's pretty much it. This is actually a really poor method or poor question, because in reality you're not going to wait, you're not going to keep measuring the pH. Like, this is, no one's going to do this. Like, that's just a very impractical way of doing this. Practical, it's just you add them together, you see it bubble, you let it just finish, and just watch it until it doesn't bubble anymore. That means you have no more reaction, and then you can just leave it in a warm place, or just put it on a Bunsen burner, and then the water evaporates and the copper sulfate stays behind. Okay, so that's a very straightforward question, I hope. So the key thing is this table. So just be really careful with that particular part. Just rewind and watch it a few times if you didn't get it before. I just have a feeling this equation definitely looks right. Okay, so hopefully this series of videos have been helpful, and if I have time, I'll definitely do some 2018 NCEA level 1 examinations, and yeah, hopefully you guys study hard, and I'll see you guys next time. Bye bye.